Alright, so today we're going to talk about stoichiometry. With stoichiometry, stoich is for element, and metry being measure. Sorry about that. So let's start out by looking at the following chemical equations. So we've got some amount of propane reacting with oxygen to make carbon dioxide and water. So take a minute and try to balance that. And once you balance it, you're going to have one propane molecule for every 5 oxygen molecules, producing 3 molecules of carbon dioxide and 4 molecules of water. And you can also think about this as ratios. There's a 1 to 5 to 3. There's a 1 to 5 ratio, and that 1 to 5 ratio is necessary to produce the 3 to 4 ratio of products. So reactants, products, and a 1 to 5 ratio of reactants to make a 3 to 4 ratio of products. If you think about it as well, you can expand this ratio, and so if you have for every 1 mole of propane, you're going to have 5 moles of oxygen, and those are required to produce 3 moles of carbon dioxide for every 4 moles of water, and that ratio kind of keeps going. So what we can also look is we can look at the number of grams of molecules in each reaction. So if we had 1 mole, and we'll multiply it by the molar mass of propane, and just believe me when I tell you that it's 44.1 grams per mole. 11 grams per mole, and that's going to equal 1 times 44 equals 44.11 grams. And then if you wanted a complete reaction, what you'd need to do is you'd have to say, okay, well now we need 5 moles of oxygen times the molar mass of O2, which is 16.00 times 2, which gives us 32.00 grams per mole, and that's going to equal 160.00 grams. So when a chemical equation is balanced, the coefficients show the ratio of the number of moles of each reactant that reacts and each product is formed. From this information, we can also calculate the ratio of the mass of each reactant and each product in the reaction. For example, if you look at what we did before, we got 44.1 grams of propane from the amount in moles from above, and so we knew that for every from every 1 mole of propane, we've got 5 moles of oxygen. So we take that 1 mole of propane and convert it to mass using the molar mass, we get 44.1 grams. We know that we're going to need, to get a complete combustion reaction, 160.00 grams of O2 to get that reaction to completely, fully occur. So now we're going to balance the following chemical equation. Take 1 second, press pause, and try to balance this chemical equation. Awesome. You've pressed pause or just ignored what I had to say. The balanced chemical equation would be 4, 3, 2, 6. How many moles of oxygen react with 4 moles of NH3? So if you look here, you've got 4 moles of ammonia. How many moles of oxygen did you need to get that to happen? Well, you needed 3 moles of oxygen. Beautiful. And how many moles of nitrogen gas are produced? So you can look at your reaction now and how many moles are produced, and you know that it's going to be 2 moles of N2 or nitrogen gas are produced. So it's possible to say that ammonia and oxygen will always react in the ratio of 4 to 3. And thus, you're going to end up with this way of looking at things. And so you can say that if you've got the ratio of 4 to 3, you can say for every 4 mole of ammonia, there's 4 moles of ammonia for every 3 moles of oxygen gas. And that's also the same way as writing 4 mole of NH3 or ammonia for every 3 mole of oxygen. It's also a possible way to set this up as a ratio between reactants and products. So if you want to compare ammonia to nitrogen, take 1 second and compare ammonia to nitrogen. Press pause and try it yourself. Hopefully you get 4 mole NH3, which is our ammonia, for every 2 moles nitrogen. Another example, this time try comparing nitrogen gas to water gas in the situation of water vapor. So hopefully you got 2 moles of nitrogen gas for every 6 moles of water. And one last one, try oxygen to ammonia. Compare the amount of oxygen to the amount of ammonia. And then you'd hopefully get 3 moles of oxygen for every 4 moles of NH3. And these are all conversion factors. Yay. Let's go to the next slide. So take a second and look that we are using the same chemical reaction as before. It's already balanced for us. So how many moles of oxygen will react with 1 mole of ammonia? So what you're going to do is you're going to say you have 1 mole of NH3. And now you have to use your conversion factor. So you need to look at the amount of oxygen you have and the amount of ammonia you have. You're comparing oxygen to ammonia. The other way I like to look at this, and I'll kind of explain that in a second, but there's 3 mole of oxygen and there's 4 moles of ammonia. And you know you're on the right track because your moles of ammonia will cancel out, leaving you with moles of oxygen. The other way you can look at this is what you want is on the top, what you have is on the bottom. But the really best way to think about this is to use unit conventions, which we've been working on. So now in your calculator, you're going to go 1 times 3 divided by 4. So take 1 second and do that, and you should get an answer of 0.7500 moles of O2. Now we're ready to go, and just for the sake of argument, we'll just list this in 2 significant digits, and we'll just say that it's 0.75, therefore 0.75 mole of O2 will react. Take a second and press pause. Try to do the second example on your own. So here we go. You say 6.7 mole times, now we have to figure out our conversion factor, so I'm going to write that right there. And you know 6.7 is moles of O2. So perhaps take a second and I'm just going to clean this up a little bit. That's moles of O2. And I know I'm going to now have to set up my conversion factor. So this is what I have, and it's going to want to be crossed out. So I'm going to write my mole of O2 on the bottom. And what do I want? I want moles of ammonia, which is NH3. Now I look at my balanced chemical equation up at the top for my coefficients. So how much ammonia? 4 moles of ammonia. What amount of oxygen? 3 moles of oxygen. So in my calculator now, I press 6.7 times 4 divided by 3. And what I get out of my calculator is I get 8.93 continued, and that is 3 moles of NH3. Sorry if that's a little messy, it's just hard at the side of the screen. Therefore, 8.9 mole of N2 will react. Alright, so let's look at our last example here, and I have a little bit more room now. So again, we've got 6.7 mole of oxygen. There's my conversion factor. Try to set it up yourself here. What goes on the top, what goes on the bottom. So you know it's mole of O2 on the bottom, so that way our two oxygens cancel out. And then I'm going to have mole of N2 on the top. Now you take a second and you look at our chemical reaction up here to figure out our numbers that go here, and you look at the coefficients and you look at these to figure it out. So you know you have, for every 3 moles of oxygen, you're going to get 2 moles of nitrogen. So let's take a second and write that in now. So you know it's going to be 2 and 3. And I just have no room over here, so I'm just going to work down below now, and I get 4.46 continued mole of nitrogen gas. And if you take a second look at it, the moles of oxygen cancel out, leaving me with moles of nitrogen. So now I write it in 2 significant digits, and that would be 4.5 mole, therefore mole of N2 will react. Good. So let's go to the next slide. Alright, so now we've gone from moles to moles, and now we're changing it up, and we're going to go from mass to mass. So before we just moved from moles to moles, now we're going from mass to mass. How many grams of ammonia are needed to react with 128 grams of oxygen gas? So if you're sitting here at grams, what we're going to need to do is we're going to need to take that amount, that mass, and change it to an amount in moles, convert it using our conversion factor or our mole ratio. Once we get to moles again, then move it back into mass. And this is kind of a little bit more sensible because we can actually measure 128 grams with a scale. We can't measure moles. So it's more sensible to work in grams, and that's why we work in grams. It just takes more work for us. So our first solution is we're going to take what we're given, switch it to moles, use mole ratio, and then switch it back to grams. And so what I'd do is I'd take 128 grams of O2, and I'd divide it by our molar mass of O2, which is 32.00 grams per mole. And that's going to equal 4.000. Why did I write so many zeros? Right, 4 significant digits. Mole of O2 times, now we're going to set up right over here the mole ratio or conversion factor that you learned just before. So you got to think to yourself, what do you have? What are you going to? I'm just going to ignore that phone, so sorry about this. So you know that you have oxygen. And so when you set this up over here, you're going to be thinking of oxygen and ammonia. You also know that your chemical reaction is 4NH3 plus 3O2 reacts to form 2 nitrogen gas plus 6H2O. And I'm sorry if I didn't write my subscripts, but I'm just trying to get this to make sense. So I'm going to set up my conversion factor or my mole ratio. And what's going to happen is you're going to write mole of O2 on the bottom because now you have these able to cancel out. And then I write mole of what I want. What do I want? My question's asking me about how many grams of ammonia, so I'm going to write NH3. So now I look up at the top of my chemical reaction, and I know that it basically works that I'm going to have 3 and 4 for my amounts. So my math I just started from on the side was going to be equal to 5.333 mole of NH3, and that's because my units have now crossed out, leaving me only with ammonia. Now that I'm at ammonia, I need to convert ammonia to grams. So how do I go from moles to mass? You're right. I need to multiply by molar mass, and the molar mass of NH3 would be 17.04 grams per mole. That causes my moles to cancel out. So by moles, see you later, leaving me left over with grams. And 5.33 times 17.04 is going to equal 90.88 grams of NH3. Therefore, 90.9 grams of NH3 are needed. Alright, so this is bonus time, and bonus time I'm going to try to explain another way of thinking about this. So let's say I went through that and you're kind of lost with the steps. Another way to think about this is when I am given this mass right here, you write that underneath your chemical equation. So I know I have 128 grams, oops, wrong spot. I know I have 128 grams of oxygen, so I have 128 grams of oxygen. And what you do is you build yourself a little roadmap. So we're going to go from mass, which is what I have right here. I'm going to go from mass down to moles. I'm going to go across to what I need, and I knew to go there because the question said I needed ammonia. So I drew my arrow going towards ammonia. I'm going to go from moles to moles, and then I'm going to go back up to my final mass. It's going to take 3 steps. Step 1, step 2, step 3. Step 1 was converting mass to moles. So I converted mass to moles to get moles. Then what I did was I used mole ratio at step 2. And there's step 2 right here. So step 1, step 2, and then finally I needed to convert from moles to mass. So I took my molar mass to convert, and I ended up with mass. So from mass to moles using molar mass, from moles to moles using mole ratio, from moles to mass using molar mass, and converting. There's another way to kind of think about this. You can also do it this way. You can take 128 grams of O2 and now compare the mass ratios. So what you can do off to the side is you can look at your chemical equation and know that you have 4 mole of NH3. And where did I get 4 from? Well, I took the coefficient that's in front of ammonia, and that's where I got 4 from. And you can take that 4, multiply by the molar mass of ammonia, which is 17.04 grams per mole, and I'm going to get 68.16 grams of ammonia. I'm going to repeat what I did. So I take the coefficient from oxygen as 3, and I said, well, we have 3 moles of oxygen, and that's going to be multiplied by the molar mass of oxygen gas, which gives us 32.00 grams per mole, which is going to make 96.00 grams of oxygen gas. So I'm going to take these, and if you look at the way it's set up, we have oxygen. We're going to want to get rid of oxygen. So what we're going to do is we're going to put oxygen on the bottom, so 96.00 grams of O2. And then I'm going to write ammonia on the top. So that's going to give me 68.16 grams of ammonia. They're going to cancel out, so there's my grams of oxygen, and grams of oxygen canceled out. And so now in your calculator you go 128 times 68.16 divided by 96. And if you punch that in your calculator, you get 90.88 grams of NH3, which is, hey, the same answer we got above. Therefore, 90.9 grams of NH3 are needed. Yay! So we're going to look at this and we're going to say what mass of nitrogen gas is expected to form if you have 128 grams of oxygen reacting or being used. So what we're going to do is we've got 128 grams, and that's of oxygen gas. We're going to convert it to moles. So that's 32.00 grams per mole is our molar mass. And so 128 divided by 32 makes a nice even 4 mole of O2. Now we take that and use the mole ratio. So you know you've got oxygen. So you're going to write oxygen on the bottom. So you have mole of O2. And we'll write mole of N2 or nitrogen gas right there. Look at your chemical equation from the very start. And in case you've forgotten, it's 4NH3 plus 3O2 reacts to form 2N2 plus 6H2O. And if that map from before really helped you, right now we're at 128 grams of oxygen. We're going to convert to mole. Once we get to moles, then we've got to use mole ratio to move across to nitrogen gas back to mole. And then you're going to find the mass by using molar mass. So here's what we're trying to find. So step 1, I've already done. Step 2, I'm working on. And so now we know that we've got for every 2 moles of nitrogen, we've got 3 moles of oxygen, which is going to give us 2.667 mole of what, you ask? Well, our units cancel out, leaving us with nitrogen, so you know that's moles of nitrogen. Finally, you've got to take that amount in moles, and don't forget, moles means amount, and you're going to now multiply by the molar mass of nitrogen gas, which is 28.02 grams per mole. Our moles cancel out, leaving us with grams, and our final answer should be about 74.72 grams of nitrogen. Now we look at significant digits. 1, 2, 3 significant digits in 128, so therefore 74.7 grams of N2 will form. Have fun with your homework. I'll talk to you tomorrow about questions.